Well, greetings, everybody. I got this question yesterday from a student, and it's from MyMathLab. I can't remember which assignment, but I'll post it in the correct place so it's linked to the assignment that this comes from. But the question goes like this. It's about creating a confidence interval, a 90% confidence interval and a 95% confidence interval, and so on. And I'll go through how you do all the calculations, but I never feel good about going through and just showing you calculations without giving you a little bit of the backstory. Okay, so I'm going to go through that real quick just so it's in your head in case you saw something that was like this but still a little bit different. All right, so here's how it works with confidence intervals. This is the scenario that we find ourselves in. There is a population. We don't know the population mean, mu equals question mark, we don't know it, okay? Sigma, the population standard deviation, we do know, okay? And we take a sample. The sample comes from the population, and we calculate x bar, the sample mean, and we know n, the sample size. And with all that, what we want is there some way to estimate what mu is, the population mean, with this information? Can I say something about it? Because it's the unknown in the scenario. You got the population, you take the sample from it, you know this number sigma, you know x bar, you know n, but mu is the number that you want to know something about, okay? All right, so yes, that's the question. Can we estimate mu somehow? And the way that we do that is we calculate something called a confidence interval. All right, so here's how that works. Big picture for the confidence interval. It is essentially the sample mean x bar minus some margin of error e on the low end, and the sample mean x bar plus e, the margin of error on the high end, okay? And what we say is that mu, the population mean, is somewhere between these numbers, x bar minus e and x bar plus e. E is called the margin of error, all right? And you find that on the normal distribution just like this, okay? In the normal distribution that you look at to find that number will have a mean of 0 and a standard deviation of sigma over root n. Now remember, sigma is the population standard deviation, which we will know, and n is the sample size. Okay, so that's how we do it. Now, and when you find E, if, for example, you want to find a 90% confidence interval, then you set this up where E and its opposite, E being the margin of error, contain 90% of the area, all right? So we'll go through and do that, but I just want to go through and tell you all the elements of solving this kind of problem, okay? All right, so now let's solve this particular problem. So it says that we have a sample of 80 days where we have the mean record high daily temperature to be 85.88 degrees Fahrenheit, okay? So we're talking about the temperature each day, all right? And then there's like every day, but we have a sample of 80 dates that come from a population, okay, of a bunch of different dates. The population standard deviation is 14.61 degrees Fahrenheit. So I'll do this part here where it says construct a 90% confidence interval. All right, so here's what we have. Population, which is just a bunch of days of weather. All right, we don't know the mean high temperature for the population, but we know the standard deviation. Okay, so we don't know mu, but we don't know sigma. We take a sample of 80 days, where among that sample, the mean high temperature is 85.88 degrees. Okay, so that's all the stuff we have. That's all the stuff I told you that we would have when we solve this kind of problem. Now, I'm going to do this part where we find a 90% confidence interval. Okay, that interval will be x bar, which is the sample mean, minus e, the margin of error, on the low end, and x bar plus e on the high end. Mu, the population mean, you know, for all the days from which this sample was taken, whatever the record daily high temperature is, okay, then we're estimating that, and that number will be somewhere between this number and this number, okay? That's what we will be able to say about it, as it's not known at the time. All right, what do we say? We find E on the normal distribution with mean of 0 and standard deviation of sigma over root n. In my case, sigma is 14.61, n is 80, so that'd be 14.61 over root 80, and I calculate that to be 1.63345. Okay, now let's look at StatCrunch, okay, so that I can find what that margin of error E is. Okay, so what I need is to look at normal distribution, which I have up already. I got to set it to between, all right. Standard deviation should be 1.63345, so I'll type that in, 1.63345, and the mean is 0. And to find a 90% confidence interval, which is the part of this problem that I'm doing, I set this to be 0.9, and then you'll get a picture that looks like the one I showed you earlier. Okay, so 90% of the area is here. That's associated with finding a 90% confidence interval. And this number right here is the margin of error, and this is its opposite, and that is 2.6868. So E, the margin of error, is 2.6868. Okay, so I found it. My confidence interval for the mean is, okay, what was it? Sample mean, 85.88, minus margin of error. Okay, on the low end, sample mean 85.88 plus margin of error. That will give you this. Population mean with 90% confidence is more than 83.19 but less than 88.57. Okay, now in MyMathLab it's input this way right here. That's fine. Put it in like that. We're just saying that the population mean, this unknown thing, is somewhere between those two numbers. Okay, now I'll leave it to you to do the 95% confidence interval. The only thing that would change is when you find this number E, you're going to set it up so that 95% of the area is here. Okay, so I adjusted that one number, so that's your margin of error in that case. All right, but still I'm going to leave you to do that one. Which interval is wider? Well, which one do you think would be wider? You know, something that you have 90% confidence in or 95% confidence. I hope your instinct is that the more certain you are about where the population mean is, the wider the span of numbers is. Okay, so the 95% confidence interval is wider. And as far as an interpretation, you can be 90% confidence that the population mean record high temperature is between the bounds of the 90% confidence interval and 95% confident for the 95% confidence interval. Yeah, that's how I describe them. Okay, I can't tell you with this for certain what the population mean is, but I'm giving you a confidence level of the numbers that it lies between.